Good evening, friends. Study with Apala, Engineering and Journal Geology, Parvin Singh book. Chapter 4 Geological Work of Water. So, drainage pattern. In any regions, a number of above described type of streams may be present. All of them contribute towards removals or drainage of any water received by that region from precipitations and other sources. The relationship of all these streams with each other and with the regions as a whole give rise to the drainage patterns or drainage systems of that area. These patterns may be of one or more of the following well-known type: trellis drainage, dendritic drainage, and radial drainage, superimposed drainage, antecedent drainage. Trellis drainage, the vents are consequent streams receive a number of subsequent streams from the right and left at approximately right angles to its direction of flow. A trellis drainage system is said to develop. It denotes regularities in the development of various constituent uh, streams. Dendritic drainage. Dendritic drainage. This type of drainage pattern develops when the streams of different types, consequent, subsequent, obsequent, etc., are all fairly common in a region and none appears to dominate other group. The overall appearance of the river patterns when viewed from above is like that of a big tree trunk, the main streams with numerous branch joining it in the middle and lower reach. Such a drainage system is characteristics of regions with broadly uniform compositions of composition in terms of rock type. Radial drainage. This type of drainage developed in regions which are either elevated or depressed with reference to the surrounding topography. Naturally, when sea from above, streams may be either flowing from a central elevated regions or flowing towards a common central regions when it is depressed. T1, T2, T2, this indicate T first tributaries and T2 second tributaries. So in this trellis drainage pattern, dendritic drainage pattern and radial drainage pattern. Superimposed drainage. It is developed in geologically old and complex fold regions. In such a system, streams do not seem to have followed the normal practice of cutting down their channels selectively. In fact, the whole systems of streams patterns may appear irrelevant to the local geology of the region. A trough study of the regions, however, reveals that the drainage systems was initially developed in accordance with the geological formation at the top, which were subsequently removed due to the erosive work of these streams. On encountering the underlying complex formation, streams did not change their course to suit the local geology, but instead they imposed their original patterns on those rocks, forming their channels. Such a system is referred to as superimposed drainage. Antecedent drainage gradually uplift of the crustal blocks forming the mountain systems is believed to be a well-established geological phenomenon. Streams flowing over such a gradually rising block of the crust of the earth are also influenced variously. Many streams may fail to adjust themselves to this activity and undergo drastic change in in their courses. In some cases, however, streams may succeed in maintaining its original course through the slowly and gradually rising blocks of the crust. This is possible when the rate of uplift of the block is less than the rate of down cuttings of the channels. By streams, thus the rising blocks eventually may become a mountain range, and the streams may still be flowing through it in a very deeply cut channels of its own. Such systems of streams that existed prior to the uplift of the areas to present status and that have succeeded in maintaining their courses through the uplifted block form the antecedent drainage. So in figure, the superimposed drainage and antecedent drainage, uplifted regions. The Himalayan rivers, the Indus, the Ganges, the Yamuna, are believed to present best example of antecedent drainage. Thank you.